Hi everyone, right now's discussion will be about engineering mechanics, which is also known as statics of rigid bodies. But before anything else, we are going to review some basic knowledge before going to the actual topic. First, we are going to do some vector and couple problems. First problem, compute the value of b if a and b are orthogonal. A is equal to 2i plus bj plus k, and b is equal to 4i minus 2j minus 2k. So orthogonal means perpendicular. Since they are perpendicular, their dot product is 0. Then we can directly substitute the coefficients in b to a. So 2 times 4 plus b times negative 2 plus 1 times negative 2 is equal to 0. Then we can get the value of b, which is 3. And for the second problem, we are to find the cross product of two vectors, which is u and v, where u is equal to 3, negative 4, 1, and v is equal to 5, 2, and negative 6. Presented in the screen is the solution. To simply explain this, to get the coefficient of I, we need to cross multiply the values in j and k. So negative 4 times negative 6 is equal to 24 minus 1 times 2. So we get the 22i. And then for the coefficient of j, we simply cross multiply the values in I and k. And for the coefficient of k, we need to cross multiply I and j. And then we get the answer of 22i minus or plus 23j plus 26k, or 22, 23, and 26. And to check if your answer is correct, multiply the calculated values to the given values of u and v, and this should equal to 0. So problem number 3. A couple consists of two vertical forces of 60 pounds each. One force acts up through A and the other acts down through D. Transform the couple into an equivalent couple having horizontal forces acting through E and F. First, get the moment of C. So force times distance, which is equal to 2 times 60, and then we get the value of 120 pounds inches. And since the force acts up through D is perpendicular with E, we will use the moment of C in getting the force P. So 3P is equal to C, which 3 there stands for 3 inches. So we get the value of P, which is 40 pounds. So next problem is a vertical force P at A and another vertical force F at B in the figure produce a resultant of 100 pounds down at D and a counterclockwise couple C of 200 pounds feet. Find the magnitude and direction of forces P and F. So we are given the diagram along with the problem. So we are given a moment in C and a resultant, and we are to find the magnitude and direction of P and F. First, moment in B equals distance, which is 4 plus 3 equals 7, times the resultant plus moment in C, then we can get P, which is 300 pounds downward. Then summation of vertical forces, P minus F is equal to 100, so we already get the value of P, which is 300 pounds, so 300 minus F is equal to 100, and then we get the value of F, which is 200 pounds upward. So in this part, we are going to solve problems on resultants of coplanar force systems. So number 1, two tugboats are towing a cargo ship as shown below. Tugboat A exerts a force of 15,000 newtons at 30-degree angle, while tugboat B exerts a force of 20,000 newtons at 50-degree angle. Determine the magnitude and direction of the resultant force acting on the cargo ship. So we are given the diagram along with the problem. So first, we have to draw a diagram to visualize the problem better. In the first diagram on the left side, it represents boat A, which exerts a 15,000 newtons force with an angle of 30 degrees, and on the other side represents both B. So to get the resultant in x-axis, Rx is equal to 15,000 cosine 30 plus 20,000 cosine 50 is equal to 25,846.30 newtons. And for the Ry is equal to 15,000 sine 30 minus 20,000 sine 50 is equal to negative 7,820.9 newtons. And for the resultant force acting on the cargo ship, we have to get the square root of Rx squared plus Ry squared, and then we get the value of 27,003.5 newtons. And to determine the direction of the force resultant, arctangent is equal to Ry over Rx, which is equal to negative 7,820.9 over 25,846.13, and then we get the angle of negative 16.8 degrees. So never mind the negative sign since we carry the sign of Ry, but in reality it is 16.8 degrees. So therefore, the ship has a resultant of 27,003.5 newtons at 16.8 degrees. So the second problem is the whole roof truss shown in the figure carries the given loads. The wind loads are perpendicular to the inclined members. Determine the magnitude and the direction in angle of the resultant force. So first, we get Rx. So Rx is 1,120 plus 2,240 plus 1,120 times 1 over square root of 5 plus 2,000. So we get the value of Rx, which is equal to 4,003.52 newtons. And for Ry, it is the summation of forces in Y, which is equal to 1,120 plus 2,240 plus 1,120 times 2 over square root of 5 plus 3,000 plus 2,000 plus 1,000. Ry is equal to 10,007.3 newtons. And for its resultant, we get the square root of Rx squared plus Ry squared, which is equal to 10,778.16 newtons. And to get its distance, which is in angle, we have tangent angles is equal to Ry over Rx. So to get the angle, we need to do arctan is equal to 10,000. To get the angle, arctan 10,007.3 over 4,003.52, and the answer is 68.2 degrees. So therefore, the resultant is 10,778.16 newtons at 16.2 degrees. So in this part, we're going to discuss about resultants of non-coplanar systems. So the first problem states that determine the magnitude of the resultant and its direction cosines for the following system of non-coplanar concurrent forces, given 100 pounds, 2, 3, 4, 300 pounds, negative 3, negative 4 and 5, and 200 pounds, 0, 0, and 4. So first, we need to solve for distance. So d is equal to the square root of x squared plus y squared plus z squared, and we get distance 1 equals 5.385, distance 2 7.071, distance 3 of 4. And then to solve for Rx, we need the summation of x times its corresponding force over its distance, and we get negative 90.140 pounds. And the same goes for Ry. We need the summation of y times the vertical force over its distance, and we get negative 113.997 pounds. And for Rz, we need the summation of z times Fz over its distance, and we get 486.41 pounds. And to solve for the resultant, we need to take the square root of Rx squared plus Ry squared plus Rz squared, and which is equal to R is equal to 507.657 pounds. And for the direction of cosines of the resultant, we need cosine theta x is equal to rx over r equals negative 90.14 over 507.657 is equal to negative 0.1776, and cosine negative theta y is equal to ry over r equals negative 113.997 over 507.657, and we have the answer of negative 0.2246. And for cosine theta z is equal to rz over r, 486.41 over 507.657 is equal to 0.9581. So therefore we have the direction, which is negative 0.1776, negative 0.2246, and 0.9581. And for the second problem, determine the magnitude of the resultant and its direction cosines for the following system of non-coplanar concurrent forces. So we have 300 pounds, 3, negative 4, and 6, 400 pounds, negative 2, 4, and negative 5, and 200 pounds, negative 4, 5, and negative 3. So again, the same thing as we did in the previous problem, we get the distance, which is square root of x squared plus y squared plus z squared, and we have the distance 1 of 7.81, distance 2 6.708, and lastly distance 3 7.071. And again, Rx summation of x times Fx over d, and we have negative 117.161 pounds. Ry summation of y times Fy over d, and we have 226.291 pounds. And lastly, for Rz summation of z times force z over distance, and we have negative 152.529 pounds. And we get the resultant by getting the square root of rx squared plus ry squared plus rz squared, and we have 296.984 pounds. And for the direction cosines of the resultant, we have cosine theta x, which is equal to negative 117.161 over 296.984 equals negative 0.394, and cosine theta y, which is equal to 0.762, and cosine theta z is equal to negative 0.514. And we have the directions negative 0.394, 0.762, and negative 0.514. Now we move on to equilibrium of coplanar force systems. So first problem is determine the magnitude of P and F necessary to keep the concurrent force system below in equilibrium. So we are given the diagram and the given forces and angles. First, we need to get the summation of horizontal forces. So F cosine 60 plus 200 cosine 45 minus 300 minus P cosine 30 is equal to 0. And then F cosine 60 is equal to 158.58 plus P cosine 30. And then we get F is equal to 317.16 plus 1.7320P. So this is our first equation. So never mind first the second line, we will get back through that. So, and then since we already have the first equation, then we can solve for P by using the summation of vertical forces. So F sine 60 minus 200 sine 45 minus P sine 30. And we already know that F is equal to 317.6 plus 1.7320P 0P. So multiplied by sine 60 minus 200 sine 45 minus P sine 30 is equal to 0. Then P is equal to negative 113.25 newtons. So going back to the first equation, we need to substitute the value of P so we can get the value of F. So 317.16 plus 1.7320 times negative 133.25 newtons. So F is equal to 86.37 newtons. And there we have our answers. So the second problem, and this is the last problem on equilibrium of coplanar force system. Cords are looped around a small spacer separating two cylinders, each weighing 400 pounds, and pass over a frictionless pulleys to weight of 200 pounds and 400 pounds. Determine the angle and the normal pressure end between the cylinders and the smooth horizontal surface. So we have a 200 pounds force pulling on the left side, as you can see in the diagram, and 800 pounds downward, which is the total weight, then a 400 pound force with an unknown angle. We need to determine first the angle by using the summation of horizontal forces. 400 cosine unknown angle minus 200 is equal to 0, and then the arc cosine of 0.5, then we get the angle 60, which is 660 degrees. And then we need to solve for the normal pressure n. So we have to do a summation of vertical forces. So n plus 400 sine angle minus 800 is equal to 0. Then we already solved for the angle. So n plus 400 sine 60 minus 800 is equal to 0. Then we get the normal pressure n, which is 453.59 pounds. And that's all for equilibrium of coplanar force systems.
Chapter 6, Equilibrium of Non-Coplanar Force System. A body is considered to be in static equilibrium or rest only when the body has no motion or movement. Non-coplanar forces are forces that act at different planes. At any case, forces will not be acting in a single plane for a non-coplanar force system. So, how do you find equilibrium of non-coplanar forces? There are three equilibrium conditions that can be used for a non-concurrent, non-parallel force system. The sum of all forces in the x direction or horizontal is 0. The sum of all forces in the y direction or vertical is 0. And lastly, the sum of moment at any point 0 is 0. Problem number 1. A balloon is moored by 3 cables as shown. The lift of the balloon is 600 Newton. Draw the FBD of the balloon and write a vector expression for the tension in each cord. So we must first draw an FBD. This 600 Newton force going up pulling on these 3 cables, which are cable A, cable B, and cable C. So we are required to write the vector expression of each tension. So we start with point AD. Square root of 20 squared plus 60 squared equals square root of 4000. For point BD, square root of 30 squared plus 60 squared equals square root of 4500. And for point CD, square root of point AD squared plus 60 squared equals square root of 4900. With this, we can now rearrange the expression of each tension. We can get the result written below. Problem number 2. A homogeneous triangular plate weighing 50 lb is suspended in the horizontal position by 3 vertical strings. Solve for the tension of each cord. So it shows here that our FBD, that the x and y axis are emphasized to make it easier to understand in finding the tension of each cords. First, we multiply 1/3 by the measurement of the triangle on both sides, which are 6 and 9. And then we multiply 2/3 again by the dimension of the two sides of the triangle. So we must always state that the summation of all forces is 0. Then we'll get the equation of this. And then, as well as the summation of moment, it must be equal to 0. Then we'll arrive to this equation and then substitute the values. After that, we then regroup it according to their places in the FBD. For tension A, we get the answer 50 over 3. For tension B, we got the answer of 15 over 3. And for tension C, we get the answer of 50 over 3. Chapter 8, Forces in Beams. Problem 1. Draw the shear and moment of the beam shown. So first, we must observe the support and connection types in the given problem. We observe that it has pin support and roller support. For the pin, it can resist both vertical and horizontal forces. And for the roller, they are free to rotate and translate along the surface. With this, we are able to know the direction of each point here present. We then solve for the reaction forces for summation of moments. We get the answer of RC, which is equal to 410 lb. For the summation of force, we get the answer of RA, which is equal to 170 lb. We then proceed in solving for the shear values. So for VA, which is equal to RA, we get the answer of 170 lb. For VBL, the value of VA minus the area L diagram of AB, we get the answer of negative 70 lb. For VBR, the value of VB minus concentration load at B, which is equal to negative 170 lb. For VCL, VB minus area L diagram BC, which is equal to negative 170 lb. For VCR, the value of VC plus concentration load at C, which is equal to 240 lb. For VDL, the value of VC minus the area L diagram of CD, which is equal to 0 lb. And lastly, for VDR, the value of VD minus the concentration load at D, which we get the answer of 0 lb. After solving shear values, we then solve for moment values. For moment A, since its support is pinned, it can't rotate, then therefore moment A is equal to 0. For moment B, we add the value of moment A minus area V diagram AB, then we'll get the answer of 100 lb feet. We can also get the value of mx, which is equal to 120.445 lb feet. Then for moment C, the value of mb minus area V diagram BC, which is equal to negative 240 lb feet. And lastly, for moment D, which is the value of mc plus the area V diagram CD, which we get the answer of 0 lb feet. Since the values are now complete, we then plot it in the diagram. So as shown here, at the upper part, which is the shear values, and the lower part are the moment values. Problem number 2. Determine the shear and moment equation from the beam shown below. Draw the shear and moment diagram. We first constructed a FBD of the beam, then we solved for the reaction forces. For RE equals to 300 lb and for RB equals to 300 lb. Then we solve it by segment. For segment AB with an FBD shown, we get the answer of VAB equal to 100x lb. For its moment, the value of VAB times x over 2, which we get the value of negative 50x squared lb feet. Moving on to segment BC, with an FBD provided, we get the value of 300 minus 100x lb. For its moment, we get the value of 300 times x minus 2 minus 50x squared lb feet. For segment CD, in the FBD shown, we subtract 100 times 6 from 300. So we get the value of negative 300 lb. For its moment, we get the value of 300 times x minus 2 minus 600 times x minus 5 lb feet. And lastly, for segment DE, from the FBD shown, we subtract 100 times 6 by 300 and we get the answer of negative 300 lb. And for its moment, which is equal to 300 times x minus 2 minus 600 times x minus 3 plus 1200 lb feet. Then after solving for the shear and moment, we then summarize our answer to organize it. Then plot the values from segment AB. The value is from 0 to negative 200, so its direction is downward. The segment BC values are 100 to negative 300, so we must stop until we reach positive 100 and change direction to upward. Since it's positive, and we'll do this until the last segment. Same goes in plotting the moment values. The positive direction is upward and the negative is downward. Chapter 9 Forces. Definition of force can be given in several ways. Most simply, it can be defined the cause of change in the state of motion of a particle or body. It is of course the product of mass of the particle and its acceleration. Force is the manifestation of action of one particle on the other. Problem number 1. The 2000 Newton block shown in the figure has an impending motion up the plane caused by the horizontal force 4000 Newton. Determine the coefficient of static friction between the contact surfaces. The problem requires the coefficient of static friction between the contact surfaces. Weight of the block is 2000 Newton and the motion of the plane is 4000 Newton. We must first draw an FBD to help us visualize the problem. Then we solve for normal force, which is the weight of the object. And the answer is 3732.05 Newton. For the force, which is its direction is sideways, we have the answer of 2464.10 Newton. And for determining the coefficient of static friction between the contact surfaces, we have the formula of friction equal to force over normal force. Then we substitute the values and we'll get the answer of 0.66. So we now proceed to problem number 2. What weight is necessary to start the system of blocks shown in the figure moving to the right? The coefficient of friction is 0.10 and the pulleys are assumed to be frictionless. So we must always draw an FBD to analyze the problem, and we also need a separate FBD for the object present to derive some equation. So first, the FBD of weight, since it has two forces, the tension that is pulling and its weight. So we got the equation of tension 1, which is equal to weight. Second is the FBD of 400 lb block, which is in the slanting position. Since its mass is given, we must find the angle of it, so it has the angle of 30 degrees, and multiply it by its mass. And we'll get the answer of normal force 346.41 lb. And for its force, we multiply it by the coefficient friction, which is 0.10. Then we'll get the answer of 34.64 lb. For tension 2, we then combine it with the first equation, then come up with a new equation, which is tension 2 equal to weight minus 234.64. And lastly, the FBD of 600 lb block, its force has normal force and the tension 2 that is connected to the 400 lb block. So we get the equation of T2 minus F2. Then we substitute the derived equation and we'll come up to the answer of weight equal to 294.64 lb. Problem number 3. How many turns of rope around a circular post are needed for a force of 10 Newton to hold of 12,000 Newton in equilibrium? Use coefficient of friction of 0.4. So we have the equation of T1 equals T2 exponent coefficient of friction beta. We already have the value of T1, which is 12,000 Newton, for T2 10 Newton, and for coefficient friction 0.4. We then substitute it in the equation and we'll get the answer of 17.73 rad. Since the problem requires the number of turns, we use the formula of beta all over 2 pi. And then we'll get the number of turns, which is equal to 2.82 turns.